All right, for problem number 7, we're going to do more of the same, except the difference is I'm gonna sketch the graph. So we could sketching the graph is awesome, but you guys need a little practice on that. So there's 2 things we're going to do. For the first part, I'm going to take this first equation, which is x plus y is equal to 4. Now, if I write this like y equals mx plus b, that really helps me graph it. So what I'm going to do is I'm going to subtract x from both sides, and I get y is equal to negative x plus 4. Now, what I need to know, my y-intercept. So the b term is my y-intercept, and that's where it crosses the y-axis, and that number is positive 1. Okay? Now, the other thing I need to know is the slope. Well, the slope is the number in front of the x. What number is in front of the x? Well, there's a number there. You just don't see it. It's 1, right? How many x's do I have there? A negative 1x. How do I write negative 1 as a fraction? Yep. So I'm going to say negative 1 over 1. Why do I want to write the slope as a fraction? Yeah, because that's my rise over run. Now, we're going to raise hands. You guys are going to help me graph this. How do I graph this equation? Yes. Yeah. On what axis, though? So we start out on the y-axis at 1. Put a dot right here. This is the y-axis. We go to 1. Now, from there, that's a point on the line. On linear equations, to get to any other point on the line, you just use the slope. Our slope is negative 1 comma 1. What does, or not, it's negative 1 over 1, not comma 1. What do we do from this point to get to the next point? Yes? Yep, we're going to go down 1 and over 1. And we can continue to do so. Down 1 over 1, down 1 over 1. And you just do that. And if you draw a line through those dots, you're just going to continue to go down 1 over 1, down 1 over 1. And then, and I didn't put the rulers out, but you guys use your books and the calculators. Try to make your line as straight as possible. It does make a difference. What? Yeah. What's the hardest part about this is I can't see what my hand is actually drawing. I got to look at the screen, and there's a little bit of a delay. All right. Well, that's the first one. What are we looking for? Like, what's the end goal of this solving a system of equations? Put it in your own words. Raise your hand. Go. Yes. Yep. If you guys were to summarize this, how do you think you would do this? You want to share that with the rest of the class? How do we summarize this? Huh? Well, we're sketching the graph to find the solution. What is the solution of the graph? Well, I'm talking about conceptually. We don't know yet. We haven't done it. But conceptually, what are we graph something. What do we look for next once we graph it? Yeah, where they have the same x and y, where they intersect. And we call it a solution because it makes both equations true. Okay. So anyways, I got to solve the second equation, 2x minus y. Or I'm sorry, 2x minus y equals 6. So I'm going to draw kind of small over here. 2x x minus y equals 6. And I want to make it look like y equals mx plus b, because the slope-intercept form, lets me graph the line by first plotting the y-intercept and then using the slope to do my rise over run, my up and over or down and over, to get the next point on the line. And after I have 2 points, I draw a line between those 2 points. What do I do first to get that to solve for y equals some stuff? Yes. Yeah. No, you were right the first time. We're going to minus the 2x. What's 2x divided by 2x, guys? It would be 1. So I wouldn't necessarily get rid of the 2x. So the easiest thing to do is subtract it, because now this equals 0, and I get negative y equals negative 2x plus 6. How do I get rid of that negative y? Yes. You're half right. This is a negative 1y. So, well, that's not a very good negative 1y. That's a negative 1y. Wouldn't I normally divide this by negative 1? Couldn't I divide this by negative 1? So remember, on equations, when you divide or multiply by a number, you have to multiply or divide the whole thing. Now, consequently, if you multiply by negative 1, it cancels out, or it doesn't cancel out, it makes it a positive 1. So anyways, negative 1 divided by negative 1 is a positive 1y. Negative 2 divided by negative 1 is a positive 2x. And then 6 divided by a negative 1 is a negative 6. How do I plot that? What's my y-intercept for that? Well, close. Negative 6. So now what do I do over here on the graph? Yeah, we have to graph negative 6 on the y-axis. What did we say the slope was? So let me write this over here so I don't keep going back and forth. Can I think of that as 2 over 1? Why would I do that? Yeah, I could do my rise over run. Remember, the top number is your rise, so I'm going to go up 1, 2, and then over 1. That's 2 points on the line. From there, guess what I'm going to do? I'm going to go up 1, 2, and over 1. From there, I'm going to go up 2 over 1. And from there, I'm going to go up 2 over 1, up 2 over 1, up 2 over 1. So I'm just going to draw my line through those points. Okay? Now, it looks to me that it crosses somewhere around here. So there's a fraction in there, some sort of decimal. If you were to guess what that is, what do you think that would be? I would say maybe 2.3 for my x value and minus 1.5 for my y value. That's an approximation. Let's find out what it actually is, though. So I'm going to go into my graphing calculator. What was that? Can somebody tell me what that was? What's the first equation? X? Plus y. It's just x plus y equals 4? Okay. Well, you don't have to get sassy about it. Okay, what's the next one?
2x minus y
Equals 6. Okay, let me double check. Well, somehow we screwed up. So let's see where we screwed up. Somewhere we made, oh, you know what? I did it again. I made a mistake. Look at this. Guys, you really got to pay attention. This graph has a plus 4 because it's negative 1x plus 4. But my scatterbrain, I wrote it down wrong. So let's erase this graph. I know. Isn't it terrible?
Dang, guys, do better. He's the teacher. He's not supposed to be giving us the right answers. We're supposed to fix it.
Yeah, guys, you're supposed to kind of catch this stuff. I can't be up here doing this all the time by myself without any help. All right, so we're going to regraph that here. So we're going to go down 1, over 1, down 1, over 1. There we go. Now it matches. And this goes up here. And I'm going to change that. Now it looks like 3.5 roughly. Technically, I'm not supposed to know, right? So I would say 3.5 comma 0.5 roughly. And then when we look at this, the algebraic solution is 3 1/3 and 2/3. So it's 3.3 repeating and then 0.6 repeating. Well, now I've got to zoom out because we got to solve it. All right, so now let's solve it. To do the algebraic one, I'm going to take this equation here and plug it into the second equation. So if I take the second equation, which is 2x minus y equals 6, and then I'm going to say 2x minus, but y is this stuff here, negative 1x plus 4 equals 6. And I'm going to zoom in over here so we can solve it algebraically. So I have to remember to distribute this 1 through the parentheses. So this is like multiplying by negative 1. So I've got 2x, negative 1 times negative x is a positive x, plus 1x. Negative 1 times 4 equals negative 4 is equal to 6. 2x plus 1x is 3x, minus 4 is equal to 6. I'm going to add 4 to both sides. I get 3x is equal to 10. Then I divide by 3. X equals 10 over 3. But if you plug that in your calculator, it's 3.3 repeating. Now to find y, I'm going to take this other equation that I solved for y, and I'm going to say y is equal to 2 times x, which we said was 10 over 3 minus 6. 10 over 2 times 10 is 20, so this first term becomes 20 over 3. I want this 6, negative 6 over 1, to be have a denominator of 3, so I'm going to multiply the bottom by 3, and whatever I do on the top, I do on the bottom. So this becomes negative 18 over 3. So y is equal to 2 over 3, which is actually equal to 0.6 repeating. Now the question is this a reasonable, is this solution reasonable? Yeah. And it says, why is it reasonable? Because we're close. It was close. In other words, what we guessed by looking at the graph was pretty darn close to the actual answer. But now we didn't have any way to know what the exact numbers were. How do you think Mr. Adams caught his mistake? Yeah, well, I looked over my work and I realized, wait a second, I think the answer is supposed to be 3.3 repeating, and when I did my math, I had 2.5. But I knew that the y value had to be positive. And so I said, well, let me go back and see if I made a mistake. And when I went back and looked at my mistake, I said, oh, yeah, there it is. Okay? All right. I'll leave this up here for you guys. Mr. Adams is getting tired. Do you see me stretching there?
Yeah.
Oh, why? Is it, why are you